mechanical. And we are starting these webinars because we're really starting to look at different ways that we can look at green ways of either heating, cooling your home, or building a house. It's been about 125 years that we've had the exact same way to build a house. That would be just with sticks, 2x4s. It has not changed. So we're starting to look at different ways that we can modify, build, and then also more efficiently run our homes. So this is really a terrific privilege that we get to have Pete Ellis time. He is the president, all sorts of other things, along with an interesting degree, which got him to running Massmann Geothermal and Mechanical. So Pete, could you give me a little bit of your background and how you became the president of this company and got into this?
Sure. Well, thank you, Beth. It's a pleasure to be here today and introducing quite a few people to geothermal technology. I'm in the chemistry world. I'm what's called a chromatographer, and that's separation science. And I worked for one of the largest environmental testing companies in the United States here locally in Minneapolis for over 20 years. And stayed in that industry for quite a long time, and helped a lot of people run their businesses, and wanted to run my own business and be the boss, and here I am. And I think even though geothermal isn't really well, in some ways it's related to chemistry and science in general. It is technical. It does fit my background, my way of thinking. So that, and also I'm really passionate about environmental science, and this dovetails well into my interests and my goals for helping not only individuals and homeowners and local municipalities with their energy goals, but nationally as well. It's every time we put in a geothermal system, it is very satisfying to see it come to life and know that an average geothermal system will take anywhere from 2 to 3 cars off the road over its lifetime. So,
really.
Absolutely, yeah. If you add up the metric tons of carbon dioxide we actually will take out of the air in a given year, it's about 120 metric tons for all of the systems that we install in 1 year. It's pretty sizable. If you think about 120 metric tons, it's a lot.
Yeah, that is. Go a little bit further into the green side, because this is obviously what we were starting this conversation with, although we got into a lot of other things. When it's green, it's alternative energy, things like that. You're saying it's taking metric tons out of the air. How is that? Is it reusing? What is it doing?
Yeah, so basically we are swapping conventional combustible materials like propane, heating oil, or natural gas, and using electricity. And well, a lot of people will say, well, the argument is, well, you're trading one thing for the other. Plants are mainly run on fossil fuels, but if you actually look at the energy mix in today's day and age, the amount of fossil fuels has come down significantly, and the amount of electricity used to power these geothermal units is where we see the savings in carbon dioxide emissions over the life of the system.
Interesting. When you talk about when you talked about that it saves a lot, there's a slide, but you've used huge numbers like propane. If we're in outstate Minnesota, propane is money. I mean, it is expensive.
It's incredibly expensive. Yes.
Yeah. So then on this is showing the annual cost comparison. This would be not including, let's say, installment of a geothermal system or installment of a boiler or anything. This is just looking at your year-over-year costs. Is that correct?
Correct. Yes, and actually, for when this slide was printed, now the cost of natural gas and propane has gone up significantly from this as well. Yep. In all honesty, if you're thinking about building a home in an area that utilizes propane as the primary source of fuel for heating, geothermal honestly is a no-brainer. whenever we get somebody coming to us that is building a new home or retrofitting an existing system that has propane, we get the project 98% of the time, because the cost savings is so significant over propane using geothermal. And then right in the middle there is natural gas as well. And we all know, we've all looked at our bills from Excel or Connexus or what have you, and we've seen the cost of natural gas go higher and higher and higher. And there's a lot of uncertainty with natural gas. You know, how it's produced, how it's stored, where it's used, what are the conditions during the wintertime. We all saw the disaster in Texas last year, and what happened there, and how that could disrupt the supply of natural gas as well. And when you use geothermal, you're actually getting free energy from the ground. Now, it's not a big electrical circuit in the ground. It's just what happens when you have geothermal is that you get a 4-to-1, for every 1 unit of energy you put in, you get 4 units of energy out, as compared
consistently.
Consistently. So
we're not really looking at the environment in order for that to work, where a snowstorm and a lot of other things can cause, like what happened in Texas.
Correct. Yeah. So, the best that you're looking at with natural gas or propane for efficiencies is approximately 0.98 to 1. So you're never going to go above and beyond 1 with propane or natural gas.
What was also interesting in this is that if you look at, there's 3 different colors in those bars. The top one is hot water, and then it's cooling, which is not we're obviously in a northern part of the country, not much cooling going on. And then, of course, the large bar is heating. Could you talk a little bit about the hot water?
Yeah, absolutely. So hot water generation is actually an ancillary benefit of using a geothermal system. So whenever the geothermal system is running, you're focusing heat in the system, and there is some heat that is left over. And we actually harness that extra heat, store it in a storage tank. So kind of this dumb hot water heater tank for future use for your domestic hot water. So that's where you're seeing why it's so much less in cost for hot water. Geothermal systems can produce up to 60% of your domestic hot water while they are actually running.
And that's just the way it runs. This isn't an extra thing that you have to heat or take care of or do. Right. So it's just the way it rolls. Wow. This is very efficient. I would say also on these numbers, since you said these are going up, we are in an inflationary environment. I'm going to say these numbers are probably 15, even 20% low.
Absolutely. And we're seeing ROIs on these systems that are coming down considerably. So when people think about geothermal, they've heard in the past it's incredibly expensive. It doesn't pay for itself. These are all kind of
hard to implement.
Yeah. Hard to implement, exactly. But although the upfront cost of geothermal is more, at the end of the day, over the life of the system, you're going to start seeing paybacks versus propane and natural gas that have come down significantly. For example, with propane, depending on how you configure your system, whether you're just using forced air or in-floor heat, and the amount of the size of the building and what have you, you're seeing returns on investment versus propane in that 3 to 6 year range. And we're averaging about 7 to 12 years for natural gas.
Yep. I can see that. I mean, propane, and that's going to be Minnesota. I mean, especially in the outstate area, that's what they use, more propane, obviously. And that would also be easier for them. Maybe we could go to the next slide and talk about the fields and how they're implemented.
Yeah, absolutely.
So in the loops, and that, if you could explain a little bit how you're grabbing this heat out of, that's a great slide. Thanks. Could talk a little bit about how this, we're going out to get the heat from the earth. We don't need to be next to a tectonic plate or anything here. We can just put it out there.
Correct. Most people think about geothermal. They think, oh, geothermal pools, New Zealand or the Ring of Fire or Iceland. Well, this geothermal, that is geothermal, obviously. This
Mm.
geothermal technology is a little bit different in that we're utilizing that consistent temperature in the earth to draw the extra heat basically between 30 degrees and the temperature of the earth, anywhere from 48 to 52 degrees depending on where you are in the state. And we focus that energy and produce heat. So the loops are important in that these loops are below the frost line, and once you
Right.
get below the frost line, the temperature of the earth equilibrates very fast to right around, I'll round it out, right around 50 degrees. And that is consistent year over year, time over time, for millennia, because what's happened is the sun is actually creating it's cooking the earth for all intents and purposes, uh,
Right.
you know, radiant heat, it's heating up the earth and maintaining that consistent temperature below 6 feet. And so
Mm.
there's three different ways that we can provide loops for different situations, and they're all different scenarios, so depending on how much area that you have. So each one of these loops will basically do the same thing. They'll extract heat from the different location. The most interesting one is the one on the right where you see the pond loop. It
Yeah.
uses the same principle. So we make sure that if a customer has acreage, they want to put a pond on their property, well, we can actually use that pond to extract the heat from the pond, even in the wintertime. So the ice only freezes down only so far. Our loops are at the bottom of that pond. If you're thinking about, I've got a huge tract of land, I'm thinking about putting in a 2-acre pond, a fishing pond, this or that or the other thing. That's about what we require, somewhere in that 1 to 2 acre range, and at a minimum, and at least 12 to 15 feet deep, so we can maintain consistent temperatures
And you'd
in the
say that that's about right. If let's say you put in a horizontal loop, are they probably only 10 to 15 feet deep?
Yeah, actually, they're about 10 feet below, 8 to 10 feet below the ground. The reason we can't go, well, we can go deeper with horizontal loops. Anything deeper than 10 feet needs to be permitted through the Minnesota Department of Health. So you'll
Okay.
see on the vertical loop, those vertical loops, because they go down considerable distance into the earth, we actually have to go through a permitting process and make sure that everything is drilled properly. Any type of fluid that we put in the loops is food grade, antifreeze. So we're making sure we protect our environment while we're also getting great energy savings out of it as well.
And when you put in the vertical loops, they're usually used, you would say, maybe more in the city because you have a smaller area with which you're going to put the
Yeah,
loops in.
typically, yes. So with vertical loops, yeah, your option is drilling. So it's a drilling rig, and in typical separation is 10 to 12 feet between each bore. So we can fit those vertical loops into a very small area. We can be in somebody's side yard, backyard, front yard, and drill four holes in a 10 by 10 area. Horizontal loops are actually built three different ways. One is just running the pipe straight out in a trench. One is a slinky in a trench. And then the other one is we actually do horizontal boring, where we use the same machine you'll see on the side of the highway for going under overpasses and things of that nature. So there's three different ways to do a horizontal loop, but the horizontal loop definitely requires a sizable amount of land in order to put those in. All three are just as efficient if you design them correctly.
Okay. So, of course, the person that most people, if they're new to this, they would like to know a little bit about the price of implementing this compared to Well, if you could help, maybe forced air furnace would be the best one, or propane. Well, propane works towards the forced air furnace
Yeah.
or fuels it. So if you could talk to a little bit of how much does it cost for each of those types of loops and why it might be more or less expensive to put in a field loop instead or a pond loop, things like that.
Yeah. So your I would say in cost, overall cost, your horizontal loops are going to be the least expensive.
Okay.
Mainly, we're just bringing out a horizontal boring machine, or we're excavating a trench and laying out tubing. Pond loop, it depends on accessibility. When can we put in the loop before the pond is built or actually filled? It's
Right.
probably the second least, and then vertical drilling is the third option and the more expensive. However, if you're looking at a bigger project, if you have a 14,000 square foot home, in some cases, vertical loops will actually be will be on par with horizontal loops, just because of the sheer amount of dirt work that you have to do and labor involved in laying out all
Okay.
of the loops.
I can see that. Um, so as it enters the house, I think we have a couple diagrams of the different houses, and what the loops look like. Now that we get a visual of what it looks like outside, what is it doing inside now?
Yeah, so inside, it's geothermal is, at the end of the day, it's reduced down to what's called a refrigeration circuit. So in the summertime, in the wintertime, you're talk, well, hey Pete, the ground's only 50 degrees. How are you heating up this air to get my home to 74 or 72 or 68 or wherever I want to keep it? Well,
Right.
what we do is we use a heat exchanger to draw. So we've got antifreeze fluid in those lines. They're again out in the earth, and they're extracting the heat from about 30 degrees to that 50-degree mark. We bring that in to the house. We add it to very cold refrigerant. So we add that heat to very cold refrigerant, which then focuses it, which then allows that focused heat to mix with your fan and the hot air, and that moves out into your system for forced air. It's the same thing with in-floor systems as well. We extract that heat, focus it, and we can distribute it into the in-floor system. So that picture on the left that you're seeing, you'll see the orange tubing in the middle. That's for in-floor heating. So
Heat.
we can do in-floor heat, we can do forced air, we can do cooling. We can reverse the process in the summertime, where now think of your home as a refrigerator. So a refrigerator is absence of heat. You're pulling the heat out, and the refrigeration circuit makes it cold. So in the summertime, what we're doing is we're reversing the process. We're actually adding the heat to the cold refrigerant, and that goes, not the refrigerant, but with the heat exchange, that heat goes outside and actually gets distributed into the earth, the earth's a pretty big heat sink. So we actually put the heat back out into the field, what we call the loop field or the earth, in the summertime. And in cooling mode, geothermal, as you saw on that chart, is hyper efficient. I'll actually show some customers, here's your cost for cooling your home every year, and it's $60 to $100. And they're completely blown away because, yes, the refrigeration portion of geothermal is incredibly efficient.
Surprisingly, actually.
Absolutely. And you'll see on these pictures that are coming up, well, this stuff looks really complicated. Well, these are a few complicated installs where customers are utilizing in-floor heat, which a lot of people are doing nowadays in Minnesota. They're adding in-floor heat to their basement slabs, or if they have slab-on grade homes, we're actually heating the majority of their home through in-floor heating. So the only thing that's different in a forced air and an in-floor heating system in your home, whether it's conventional or geothermal, is the geothermal heat pump. And the geothermal heat pump looks a lot like a traditional forced air furnace. As you'll see on the left here, those are traditional forced air furnaces mixed together with geothermal. The forced air furnaces are backup. We have so we have backup systems with our geothermal, whether that's boiler, electric strip heat, or using a boiler to provide hot water above the geothermal. And now you say, well, I'm still using natural gas or propane if I'm doing a backup in that way, but we're only pulsing in a small amount. So that small amount of conventional heat is actually calculated in your cost comparison as well. So it's a very, very small amount if we have to use it all at all. The only reason we would use supplemental heat is when it gets down to, those days where it gets down to 30 below, 28 below, 30 below, we'll pulse in a little bit of heat.
Okay. Well, everybody needs supplemental heat those days.
Yes, absolutely.
Can you talk a little bit about what the training is for this? I mean, this isn't your normal HVAC system.
No, it isn't. So the heat pump is really a specialized piece of equipment, and it actually, you're the picture that you see behind me, the forced air geothermal packaged unit. It acts just like a forced air furnace. It's got a blower in it. It's got a coil in it. But for example, our technicians are specially trained to work on geothermal equipment. So in HVAC school, they teach you about geothermal for about a week. So we don't, the geothermal people do not grow on trees. And you need to be very careful when you're choosing a geothermal contractor to really ask tough questions. Does that contractor specialize in geothermal? How many systems do they put in a year? How many years have they been in business? How do they perform services? What's going to be the longevity of my system? Are you going to be there to take care of it in the future? So the training is very, very specialized.
When you say that too about being specialized, are there any laws, rules, regulations, things coming up at a national or state level that they're starting to hold geothermal and some of these more green organizations coming up that it's like, no, you gotta stay within these guidelines, things like that?
Yeah, there are, and you're seeing this now on the East Coast in New York and Pennsylvania. Just recently, I was in Syracuse for some training on ground source heat pump loop field installation certification. And there's several municipalities in that part of the country that are mandating that you can no longer install combustion type conventional furnaces. They all have to be heat pumps, whether those are air source or heat source heat pumps. So those states, the state of New York was requiring what's called International Ground Source Heat Pump Association certification for designing loop fields. And you need to find a contractor that has those certifications. For example, our organization maintains IGSPA, International Ground Source Heat Pump Association certifications, and Minnesota Geothermal Heat Pump Association Master Installer certifications, along with all the other refrigeration, hot air, gassing, all of the certifications that you should have.
As long as there's certifications. There's a couple different questions coming up. What is some of the maintenance on it?
So maintenance is just honestly, if you're have a forced air geothermal system, your maintenance is just like a typical forced air furnace in your home. So changing out filters and maintaining clean ducts, things of that nature. Maintenance further on down the line, 5 years or so after installation, we will come in and clean heat exchangers, things of that nature. Make sure that the entering and exiting water temperature on your system is within parameters so that you can get the maximum efficiency out of your system. Even though these systems look very, very complicated in the background, the maintenance for these systems a lot of times have less moving parts than conventional systems when you think about the AC condenser outside and the furnace fan and things of that nature.
Okay.
So maintenance is very, very, very similar to conventional systems. You're seeing all this
Clean.
yeah, you're seeing all this tubing and whatnot in the background. In an in-floor system is an in-floor system, and that's going to have the same maintenance whether you're using conventional means or geothermal means.
Okay. What are the typical service lives of ground source and air source systems?
So ground, I can mainly speak to ground source heat pumps. In my experience, air source heat pumps, because of just the nature of them, are probably on par with conventional systems. Excuse me, air source are in line with conventional systems. Ground source systems typically last in that 25-year range. So a little bit better service life and operability life with geothermal systems. And again, the ancillary benefit of having geothermal in your home when you're ready to change out your system in 25 years is your ground loop is already installed. So you don't have to re-drill your loop field. That investment and that loop field is already there to be retrofitted or changed out with a new system.
Nice. Is geothermal shareable? I think we kind
Absolutely.
of stepped on that.
Yes, absolutely. There are actually out in New York, and Ohio, and there's a few installations here in Minnesota where on the commercial side of things, where you install a large loop field, and several homes and or businesses can actually utilize that ground loop system and for several different installations. So you could have 20 homes on a system, you can have 5 homes on a system, you could have a small development that can have a centralized loop field as well.
And that would make it even more efficient?
Absolutely. Yeah.
So like with the hot water and
so the hot water efficiency is still the same, but instead of having one person utilizing natural gas and that entire small development can utilize geothermal and leverage the efficiencies of a centralized loop system.
Do you see that happening at all? Do you see builders getting interested in this in any way, or do you think it's going to have to be a force of nature from a group of people that want to live on a more less carbon footprint than they are now?
I think the writing's on the wall. I gave the example of the East Coast, and a lot of times, like it or not, what happens on the coast a lot of times trickles down to where we are.
Right.
And if the state of Minnesota decides to follow certain initiatives in those states, I could potentially see mandating that we go to heat pump systems for future installations for heating and cooling our homes. And if and when that happens, we'll have to really look seriously into shared geothermal loop fields.
It would be wise. Are there any things beyond? I think you've mentioned a lot about the benefits. We've gotten into some of the short-term and long-term costs and rewards. Is there anything we might have missed that you think you'd really like to make sure that is covered?
Yeah, I'll reflect again on cost. And it's always a big one.
Yeah.
It's one of the first things that I get hit with when I'm asked about geothermal. And the thing that you have to look at is, yes, there is a large upfront cost, and that shocks people. But we also have to look at our over time, that your conventional system starts off down here, your geothermal system starts here as far as costs. But over time, that geothermal plane ends up pretty flat because the operating costs are the same year over year. And even though the conventional system is, those costs might go up and down, but the cost to do that is a lot more. So it ends up on this trajectory here, and your geothermal trajectory ends up down here. So for example, on propane, even with that large upfront cost, with geothermal in installation potentially being 50% more than a conventional system, you're going to see a payback in 5 years. And after that 5-year point, you're just going to be generating cash.
Yeah. So the long game and the short game.
Yeah.
is kind of what we're talking about. Also, if it was shareable, I think people would see it differently. Like, you know, how they're
Absolutely.
thinking about solar energy. They're like, well, I can share it. I'm going to do that. They kind of see this cost benefit, where I think with this is, it's a great and very efficient system. So, I mean, you've educated me well, and I appreciate that. It's hard to get people to say, yeah, but you're going to put this much more down, but how long are you going to live in the house? You know?
Yes, exactly. And the government has recently helped us out in that regard as well.
Good.
They with the Inflation Reduction Act, they've reinstated the 30% tax credit for ground source and air source heat pumps. So that how that is taken into account your entire cost of your geothermal project, you get a 30% tax credit that is payable. You know, basically, so if you install a system in 2023, you'll get a 30% tax credit for the 2023 tax year payable in 2024. So that reduces the upfront costs as well.
Are there any visible red flags one could look for on existing older systems?
Absolutely, yeah. Increase energy usage. So if you have an existing system that is using a lot more energy than you think it should be, then your entering and exiting water temperatures probably should be checked. Just your system health in general. Again, we come in and take a look at heat of extraction, heat of rejection, entering and exiting water temperatures for your geothermal system. Those are pretty easy checks for us to do. So again, more energy use. So if you look at your bill and go, wow, I'm actually using twice as much energy this last month than I did the month before, it's probably an indication of a system that isn't running at peak efficiency.
Okay. And usually what I've found is maintenance overcomes a lot of any big issue.
Absolutely. Yeah. And we recommend at a minimum that you have someone like us come in and check your system out every 2 years.
Wonderful. Well, Pete Ellis from Massmann Geothermal and Mechanical. This has been a slice. Tons of great information. I hope it's been helpful to people that are seeing this, and also that we get to learn just a little bit more of better ways to create green homes in a green environment. This was delightful. Thank you.
Yeah, and I guess my parting shot on the green way of doing things is, yes, I'm running into a lot more builders that are building with ICFs with more energy efficient homes, and geothermal certainly is a great bolt-on piece to that. It depends on what side of the fence that you're on. If you want to just save money, it's a great thing for two different camps. If you want to save money over time, geothermal is a fantastic system that can heat and cool your home with forced air or in-floor heat. Mm-hmm. If you want to be green and be sustainable, again, the same thing like we mentioned early on in the conversation with reducing the amount of carbon that's emitted into the atmosphere, it's fantastic. And as far as maintenance, and like we said with maintenance, similar maintenance to conventional systems. So it makes geothermal a really smart choice if you're looking to build or even retrofit or refit a rebuild or a new construction type of home.
I agree. And now they get an idea that it's out there, it's possible, and that that's the first step. As soon as we start educating, as soon as everybody starts to see the possibilities and educate themselves on it, that's the next step is implementing.
Yeah, and we've been doing this for 20 plus years, and the technology just keeps getting better and better with geothermal systems. We're at a great point in the life of geothermal. It's been around for many years, but yeah, more people are installing these systems
and comfortable with it. Thank you again. It was a pleasure.
Thank you, Beth. Appreciate it.
Have a wonderful year, and we're before the holidays. Hopefully, happy holidays too.
Yeah, happy holidays to you too. Thank you.
Thanks.